I'm going to give you a quick demo of this Hewlett-Packard 16500B logic analyzer. I'll tell you a bit about it while it starts itself up. This dates from the early 90s, and it's got a bunch of different modules in the back for doing different types of measurements. It's got a 16550 I think 96 channel logic analyzer module in it, and it's got 6 channels of analog scope as well, which is particularly interesting. It's fired up now. You can actually see all the modules plugged in here. There's the 100 megahertz state and timing module at the top. That's the logic analyzer. And there are 3 lots of 400 megasample scopes and the time base in the bottom slot. I've been using this one in the lab for a while, but I've replaced it with a newer module, newer model, so don't need it anymore. Inside the box, originally it would have had a hard drive in. This has a compact flash card instead. It's been modified, so there'll be no hard drive problems. Sorry about the flicker on the display. That's an artifact of the camera filming the CRT. I may be able to improve it by turning the brightness down a bit. No, let's leave it bright. Yeah, the display itself doesn't flicker, but this is what happens when you stick a digital camera in front of a CRT. Unfortunately, not a lot I can do about that. With the logic analyzer, I provide various bits and pieces. There are a full set of cables for the logic analyzer channels, all 96 channels, but no pods because I don't have any spare ones. There is the Ethernet transceiver to plug in the back, so you can plug in standard Cat5 Ethernet to it. And there's the feet that go on the back, which tend to get broken in transit. There's also a boot disk, in case you want to do something with the hard drive. And there's also the nice fabric pocket that goes on the top to carry all the bits and pieces with it. First thing I'll do is run through the self-tests to prove it's all in good shape. For that we select the test system. Notice it's a touch screen. It's an infrared touchscreen, so it requires a particular style of, you have to be quite positive with your finger. But if we test the mainframe first of all, run all tests. This takes a while. Can't remember how much RAM this has in, but it's got a 68020 processor, so it's reasonably swift in operation. This will test ROM, RAM, the HPIB interface, which I've never used, but it probably works. The RS232 serial interface, the Hill, which is HP's special mouse and keyboard interface. There's one here. I'm not providing a mouse and keyboard with it because the touchscreen is enough. Test the floppy and hard drives and the various internal connections between the modules and the display. So it's just running through the RAM test at the moment, and we'll let it junta through there. This is the one that takes the longest. I've got various signals set up to test the analyzer on later, so we can do some actual captures with it and prove that it's doing what it should do. So we'll let this test finish. We can adjust the contrast and brightness on the screen. There's plenty of, oh there we go, plenty of brightness on there. There's also a handy button here for disabling the touch screen if you want to point at things, which is kind of useful. You press that, little yellow light comes on. Avoid disrupting it. Okay, it's doing the disk tests at the moment. It's doing lots of reading and writing to the hard disk or the compact flash card. And we'll let this finish. Now I can promise that some of these tests will fail, and there are good reasons for that, which I'll explain when we get to them. It's quite a comprehensive set of self-tests. It's not very interesting to watch, so I'm sorry about that. I ought to be doing this in the dark really to increase the camera shutter length so we don't get less flicker, but it's a very sunny day today and the office has big windows, so we have to put up with a bit of flicker, for which I apologise. Okay, disk test is I think now completing. You can see the little star at the top right. Oh, there we go. So, ROM test passed, RAM passed, HPIB passed, RS232 failed, and the reason for that is we don't have an external loopback cable on there. Well, that's fair enough because we haven't got one, but internally it's working. A hill test has failed. Run that. It says controller and front panel. It occasionally says there's a touchscreen failure, but I've never worked out why. Sometimes running your fingers around the edge to clean the sensors works. Try again. Oh, there we go. It doesn't fail anymore. Fixed it. There we go. Passed. So it just gets dust in the bottom, which, you know, messes it up. I've never had a problem with the touchscreen. Disk test fails because there's no floppy in the drive, and I haven't got a Gash floppy lying around to try it out with. So that's to be expected. Everything else passes, so we're in good shape. Let's test the logic analyzer module quickly, and I shall press test. Tests all the various chips on there, all passes, and we'll test the oscilloscope modules. Press that and test. Now this has 6 channels in, which is 3 16531 modules and 1 16530 time-based module, I think. It's quite unusual to find one of these analyzers with the analog scope modules in, but they're really useful because you can correlate analog measurements with digital ones. Oh, it's interesting, the event delay test has failed there. That doesn't usually happen. Let's try and test that again. Remove any connection to the external trigger VNC. That'll be the problem because I've got it set up for a testing, and I've got something connected to the external trigger. So I'll disconnect that, try again. There we go, it doesn't fail. There we go, it's my own fault. So all tests passed. I'll connect that back up again. So that's the internal self-tests. We'll return now to the main menu, and I'll show some of the things working. Oh, and also some of the configuration options which are useful. So it's effectively rebooting now. Just have to wait a moment for it to get everything going. There we go. So it's got Ethernet and various other things, and Ethernet works fine. You can do some remote control with it. You can do X. You can make it connect to an external X server, so you can drive it remotely. You can configure the IP address and router and so on as you wish. So bearing in mind it's a very old implementation of TCP/IP, so it doesn't do security or anything like that, but it does work. I've used it that way many a time for doing screen captures and things. You can also set up a printer if you like, various types of HP printers over the serial port if you like, or HPIB if you happen to have one. Let's just test the logic analyzer quickly. I will go into the logic analyzer module. Now for this I've got a few of the channels. You can see all the pods laid out here. There are 16 channels times 2 on each of 3 cables, which is a total of 96 channels, which should be enough for most people. What I'll do is just I've got only one pod connected up, which is 3 and 4, so I'll assign that to machine 1. How's that configured? That's good. And I've actually got a logic board over here with some SPI signals on that we can look at. It's only connected to 4 or 5 channels, but if I switch that on, you can see there's little indicators that there's activity on those logic lines. If I now format that, we'll put it in transitional mode. TTL threshold should be fine, and we'll assign the first label. We have to assign the signals to a label. That's label 1, that'll do, and then you can tap on here and you put stars in the spots where you want that label to be sensitive to logic signals. So we'll do that. I think those 5 are all active, so let's have that. There we go. So that's that label assigned with those signals. And we'll go to the trigger. We want to trigger on, hang on. Let's put it in binary so we can understand it. Condition A, I think, which signal is it that's got the clock on it? Just check my documentation. Okay, so it's going to be bit 0. That should go to 0 to indicate that there's activity on the SPI bus. So we'll trigger on everything don't care apart from the bottom bit, which should be 0. So our trigger conditions set up, acquisition control, sample period. Well, let's set the sample period manually to make sure it's something reasonable. Maybe, I don't know, 200 nanoseconds. And that should, the trigger is set up. waveform. Let's make sure we're displaying everything that we want. So let's label 1 bits 0 to 4. That's all good. So there we go. Now we should be able to run and capture some data. Oh, there we go, it has. So it's captured some data, and we can just zoom out a bit. There we go. You can see a load of SPI traffic there. It's actually an LCD controller. We can scroll around with that. It's reasonably swift to use. Look, you can see some traffic going on, and if we find that bit there particularly interesting, we can zoom in a bit. And there you go. Look, you can see SPI data. There's 8 clock signal, 8 clock cycles, and individual data going on there. So that's the logic analyzer basically working, triggering off one signal and displaying 4 more. Now I will show you the oscilloscope. Trying to keep this short. Now this I haven't set up properly, so first of all we'll set it to external trigger. I've set the wrong auto scale by accident. That isn't going to work. Excuse me, I'm going to have to wait for that to finish because there's no signal. There we go. Oh yeah, there is actually a signal connected to channel B1, but we don't want it. So we'll set it on external trigger level, probably about 100 millivolts because there's quite a small signal in there. Done. Slope negative, seconds per division, so we should be able to run. There we go, that captures okay. Now we'll test the channels one by one and do some rise time measurements to prove that it's working properly. Let's delete all the channels and just put channel B1 for now. And in display we can put a few things on to make it easier to read. So there's the channel, the data it's captured on channel 1. If we put it in repetitive mode, there we go, there's this signal. Actually I'd like to trigger on the other edge if I may. Positive slope, there we go. So that's displaying data. We should be on 50 ohms, not 1 mega, that's why it's noisy. Just because of the... There we go, there's a nice signal for us. Oops. So that's the rise time on channel B1, and I think up here we can do auto measure. There we go, it's measuring the rise time for us at sort of wandering around 3.3, 3.5 nanoseconds, which is spot on because this scope module is rated at 100 megahertz, and with the usual formula 350 over rise time in nanoseconds, that's the bandwidth I would expect. Let's just check the other inputs. If I move the plug across, the inputs are on the back of the machine here, so you need long cables, but that's not usually a problem. There we go. I input B2. So delete all and put B2 in. Oh, come on then. There we go, it's B2. Well, it's a bit laborious to keep changing everything. There we go, there's B2 working absolutely fine on 50 ohms. Let's just make this so we can see more clearly. And in fact, we'll check channels C1, C2. C1. You can store setups on this on the hard drive. So if you've got a particular setup of your scope or logic analyzer, what have you, you can save your favourites. I got it in the wrong socket. Let's try that. There we go. C1. Oops. Behaving properly, there we go, and we'll move plug to C2. I'll find it. Let's try that one. Delete all. You can create all sorts of displays overlaying different signals. You can have multiple ones on the same screen if you want to. Oops. There we go, so that's, oops. Oh, we're still displaying input C1. There we go, there's channel C2, works fine. And let's just do the last 2 channels on the same screen. So that should be D1. If I go, delete all channels, and put in D1, and then you can replace, insert channel mode, overlay, there we go, and you can even do maths between if you want. Put D1 and D2 there. Oh, we've actually got D1 displayed twice, that's interesting, isn't it? So there's D1, and let's just bring D2 onto the screen a bit. So I've accidentally now set up the screen, so we've got the D1 displayed in twice. If I just move the plug, there, D2 should be active. There it is, the green one at the bottom. So that's all the oscilloscope channels working, logic analyzer channels working, and that's about it. Thank you for watching this demonstration.